So Johann has already mentioned this MD on SSD work that we have been doing over multiple releases. Also highlighting some of the internal architectural changes and challenges that, of course, arise as we have moved towards having concepts of cold or paged out metadata versus metadata that is sitting in the system. I wanted to show just a few slides from a practical perspective. As a user, I mean, all of that is essentially not too relevant for me. I just want to create a pool and understand what are the knobs, what can I do in the different levels of the code that we have. So let me briefly walk through the architecture stuff. Johann already showed that right on the left-hand side. We have in DAOS, we always had a bulk storage interface through SPDK to the SSDs, and then essentially a load store interface where in the PMEM world, we had a file system on PMEM. We have files in that PMEM file system that are memory mapped, and then we can load store to that, and everything is persistent because the media are persistent. And when the Optane roadmap was discontinued, essentially, we moved to that model where we're doing load stores into files in TempFS, and of course, that is not persistent. We have to do this write-ahead logging, and then also regular checkpointing of the versioning objects or tree structures that are now sitting in DRAM. So that change happened a while ago, and Johann already showed the pictures, so I can go quick on them. This is the PMEM world where we have the WAS files in a PMEM file system memory mapped, and then the data blobs on SSD. When we did the first generation of what we call metadata on SSD, the blue stuff is now in DRAM. The metadata blob in phase one was exactly the size as the DRAM, as Johann already mentioned. And what's circled in orange here is essentially that the metadata blob is bigger. In terms of scale, the picture isn't really adequate, right? We are targeting or expecting that the meta blob, of course, is multiple times the size of the DRAM and not just 30% more. And exactly determining how much larger we can make this will also require a lot of more testing. So in the 2.8 release that is about to be released, this phase two, where the metadata blob can be bigger, is still in a tech preview while we are working through all of the internal behavior changes and proper sizing recommendations. I believe from the latest conversations we had with Liang, who also presented that at the last DAOS user group, something like a factor of 4, metadata blob is 4 times bigger than the DRAM size, is certainly something that we want to experiment with now. How much higher we can drive that still remains to be determined, depending on the testing that we're doing. So the first question, of course, is how do you figure out which of those modes are you actually running in? From a server perspective, the easiest way to do that is to just look at the DAOS server YAML file, right? If you have configured your storage class memory as class DCPM at the very left-hand side, this is from the old data center persistent memory marketing name for the PMEM. Then you know you're in PMEM mode, right? And then you have a second class called NVMe with all your NVMe device names, or if you're using VMD, the VMD controller names. So that's pretty obvious. You can have the middle ground, which I call ephemeral. That's, for example, what Google had been using for a while, where you are pretending that you have persistent memory, but it's actually living in RAM. So we would use PMDK. You can set up a file system, use it, but as soon as you power off the system, the file system is gone. Right? So for ephemeral scratch, that's fine. But that's not MD on SSD. That is essentially using the PMEM mode without physical persistent media. The real difference is shown on the right-hand side. If we switch this mode from the PMEM mode to the MD on SSD mode, the way to determine this and to configure that in the YAML file is to assign BDEV roles to the NVMe class. And the SCM size here is only for demonstration purposes. We do automatically calculate the size given the given server main memory population. In this picture here, this is what we also will do in the HPE product, initially at least, where all the roles, the write-ahead log, the metadata blob, and the data blobs are all spread across all the disks, essentially. There are options to separate that out and have dedicated disks for special functions. And in particular, for example, if we're looking at QLC that Johann had on the chart for our later release, you don't want the QLC data and the write-ahead log on the same media, right? Because of endurance concerns. And in that case, we would be able to split that and have different classes of NVMe disks with different roles. But from a performance perspective, and also because right now our media are all the same, it makes much more sense to have all roles on all the media. Those structures like the wall and the metadata are per target, just like the data blobs, right? So if you have 16 targets on an engine, there will be 16 sections of storage, right? And each target, each user level thread will use one of those sections. And if you have 4 disks, essentially that means you cut each disk in 4 pieces. As you add metadata on SSD, there will also be like 4 wall areas and 4 metadata areas on each of the SSDs. So it's nicely balanced, and all the performance work with the current generation hardware has indicated that this is actually the best we can do, at least for the range of number of disks that we have right now. So with 4 disks, definitely, if you go to like 8 disks or higher per engine, at some point it may be useful to have dedicated specialized hardware, but for now we're essentially just sharing everything on all the disks. So that's how you configure this. There's other stuff like this control meta stanza in the config file, but the easiest really is to look at how the storage devices are configured. And then as a user, as a storage administrator, more precisely, DMG pool create is the command to actually create a storage allocation, a DAOS pool, and the most or the easiest parameter to do that is to use the size parameter and tell the system I want whatever 100 terabytes. There are a bunch of other parameters there, and it can sometimes get confusing. So I have 2 slides here to show essentially how to use those different combinations of things. The easiest, most straightforward is to use size, and then there is something called the tier ratio, which I'll show on the next slide in a bit more detail, that essentially determines how much storage class memory versus how much NVMe memory will that pool get. And then whether or not you scale your pool across a subset of your engine ranks or all engine ranks, the system will automatically calculate the size of the pool. If you want to do that manually, this magenta colored SCM size and NVMe size are an alternative to that, where you specify on a per engine level the total absolute capacity of SCM size and NVMe size. That is sometimes for testing more convenient if you change the number of engine ranks, right? But in general, I think from a user perspective, the size plus tier ratio is a bit more elegant to get a storage allocation. And then as we move to MD on SSD, in principle, the size and tier ratio can also be used. There's some subtle changes depending on if it's phase 1 or phase 2. And if you want explicit control, just like the SCM size and NVMe size in magenta here, the 2 options in orange are the equivalent for MD on SSD. So you could specify the data size, which would correspond to NVMe size, and you can specify the metadata size, which in phase 1 MD on SSD is the same thing as the SCM or DRAM size. And that then changes in phase 2. For phase 2, there's a new parameter that will be that is not in 2.6. Right? 2.6, you could run phase 1 of MD on the SSD, but not phase 2. With 2.8, there is a new option called mem ratio that determines what is the capacity ratio between the stuff that's living in DRAM and the stuff that's living in the metadata. But let's look at PMEM and phase 1 first. So there's 2 things to be aware of, and people who have been running DAOS in production for a while for sure know that, but people starting fresh with DAOS, including some of our HPE colleagues, have been running into those issues of understanding how things work. So I thought I'd summarize things here to call out the gotchas. The first thing is the tier ratio. We have a software default that says essentially tier ratio equals 6,94, which means 6.00% should be allocated to storage class memory and 94% should be allocated to NVMe. And when you use this option, the total has to add up to 100.00%. You cannot specify finer grain than that, but at least 2 digits you can use to specify the ratios in some scenarios where that is necessary. And we've been using that from day one. This is one of the things where we don't have better defaults yet. And at the bottom of the page here, I listed a PR, not a PR, a Jira ticket that we have to like look at. Can we make this more automated? Because the challenge with that is that actual DAOS server hardware doesn't necessarily align with what the default in the software is. And I showed the 3 PMEM systems that are on the IO 500 list, for example. Aurora has very large NVMe drives and actually has a DRAM tier of 3.5%. LRZ has very small SSDs and only also a smaller number of SSDs. They are slightly above the 6%. And the Lise machine in Berlin is an older generation system, so it has fewer memory slots. And that machine has a tier ratio of roughly 5%. So hardware dictates what you actually get. And there's two implications of this mechanism on how we structure the sizing of those 2 tiers. The first one, which is a bit annoying and for an end user, is that the size parameter itself actually is the total of the 2. Whereas as a user, I don't really care how much SCM DAOS needs internally. What I care about is what's the space that I can get as the user. Right? But that's only 95% of what you specify on the command. So if you want 100 terabytes in the default scenario, you actually have to divide that by 0.94, right? And you have to allocate something like 106 and a bit terabytes to get to the 100 terabyte usable. So and that's been there historically, like since day one. But I think it's not really user friendly because you always have to do that conversion. Maybe at some point we can consider changing that as well. The K3000 software will actually change it. So if you create a pool to K3000 commands, what you specify is the NVMe size, and everything else will be calculated around it rather than the other way around. So that's one thing. And the bigger the SCM capacity is, the more relevant that factor is, of course, right? If you have 0.5% SCM, then the difference isn't that much. But if you have 6, then that delta is significant. And the second one, which is much more than just an inconvenience, if you're not careful and you're not specifying a tier ratio that is reflecting what you have in your actual hardware, you will end up with like having stranded NVMe capacity. Again, example of Aurora, 3.5% instead of 6%. If you would not specify the tier ratio when you do pool creates, you would essentially waste 40% of your NVMe because you run out of SCM before you have allocated all the NVMe, right? So it's really important that on a system with actual hardware, right, the scripts that allocate the pools take into account what is the capacity in the system, and then change the default tier ratio to do that, right? I haven't seen us run out of those 6%. I think most of the time we're staying significantly below that, except when people are running like MD test and filling up the system with billions of files. So in the end, I mean, it may be beneficial to have some pools with more SCM, some pools with less SCM, depending on like knowledge of the use cases. But for sure, if we just run with the default on a system that has less of this like storage class memory, that creates a problem when at some point your system is full essentially, and you have to delete pools to change things. That statement is true both for PMEM and also for MD and SSD, because for MD and SSD, essentially your metadata blob and the DRAM size are identical. I think we'll definitely have to look at how to make this more user-friendly. Of course, on the HP product side, there's wrappers around the core DAOS stuff that we can use. But I think in general, this could be more user-friendly in getting people like without all the extra mass, the capacity that they want on the NVMe side. If you're looking at what's actually in the systems that we intend to like sell as products, at least on the HPE side, this matrix shows on the x-axis the 3 disk capacities that will support in version 1 of the K3000 product, and then on the y-axis the number of drives that will support. And there's a bunch of conversions there between base 2, base 10, and essentially in the bottom right on each of those squares you see the actual SCM ratio. And for most of the configs it's 0.88%, right? Some are above. And the one with like 20 of the 15 terabyte drives, it's actually 0.7%. So that's what we get in reality in a DAOS system with MD and SSD phase 1 today, right? And the metadata is much, much smaller than what we had in the PMEM area. And we're sort of counting on the phase 2 implementation to make sure we can hold more than this 0.8% of VOS space, essentially, by staging cold metadata out to the metadata blobs. So let's look at that. What changes when we are moving to the MD on SSD phase 2? There's no change in the configuration. The server YAML looks exactly the same. How this will differ is by using this mem ratio option that is new in DAOS 2.8. And of course, the physical hardware is still the same, right? If I have a server with, let's say, the maximum number of drives, maximum capacity of drives, and 2 terabytes of memory, that's what I have, right? I cannot create more DRAM than the 2 terabytes in the system. Whereas the metadata blob lives on the SSDs. If I have 300 plus terabytes there, of course, theoretically, I can grow the meta blob very, very large. The question is, how does that perform with all the architectural challenges of like, which of those sections do we pin? How do we page things in and out? All of that, those questions that Johann mentioned briefly. So it's not clear as of today, I think, how much larger we can do the memory, the metadata blob versus the memory. What I'm showing in the 2 gray boxes here on the left-hand side, this is the phase 1 where you don't specify mem ratio, or which means you get the default mem ratio of 100%. And this is on a system that has 20 of the 15 terabyte drives. It has 2 terabytes. The raw capacity was, let me see, on base 2, 307 TB bytes. And I'm just creating a pool here of 300 terabytes with a tier ratio of 0.6% FCM and 99.4% of NVMe. And you see the results. We are printing a warning that this ratio is low and then allocating 0.6% SCM. And the numbers roughly add up, right? At the bottom, you see the data storage is 298 terabytes. The metadata storage is 1.8. So add those together and you get to the 300 that I requested. So that's metadata on SSD phase 1, right? And you are limited by the 0.6% of total SCM. So if you have a lot of files or files with like very wide erasure code striping that causes like the replication of the metadata to all of the EC strips, then at some point it's likely that you will run out of SCM space. And so the phase 2 way to create a pool is available as a tech preview. You can have phase 1 pools and phase 2 pools in the same system with DAOS 2.8. So you can decide that you have your production pools created with metadata on SSD phase 1, and then start experimenting with a different mem ratio on some pools just for that purpose, right? Without necessarily risking any impact to users if you're experimenting with features that are like not perfect from a performance perspective, for example. And to go to the default that we have in the system right now, I just do the same command on the right-hand side, specifying the default tier ratio of 6% and 94%, and then cut down the DRAM capacity to 1/10 of that. So we essentially have the same allocation in physical media. The way the option works right now is the opposite of what I would naively think it is. So essentially, the mem ratio tells us how much smaller the DRAM is relative to the metadata blob. But I'm more a hardware guy. For me, it would be more natural to think about what capacity do I have in DRAM and how much larger would the NVMe tier be. But of course, in the end, it's the same mass stress, like multiply by or divide by, essentially. So the way the API is structured right now, the mem ratio tells us how much smaller is the DRAM taking the base, the metadata blob size as the base. And one thing that also needs to be noted, this tier ratio that we use for PMEM and for MD and SSD phase 1, in that case, we could think about it as the DRAM space because the mem ratio was 100%. In this scenario, it becomes clear that the tier ratio, like the SCM there really is not the DRAM, it's the size of the metadata block. So if you look at the results at the bottom, you see that now our metadata storage is 18 terabyte, not 1.8, right? And the DRAM capacity which is not shown here explicitly. Oh, it is shown at the very bottom, where it's still 1.8 terabytes. So there's a factor of 10 or 10%, depending on the direction in the calculation here. What you also notice, our control system is not particularly good at math. It's now giving me a 6.38% ratio. I'm not sure if that's rounding because of some like chunking or block sizes, or if it's just a math error there, but the stuff in the bottom looks consistent, right? We're getting the same DRAM memory and we're getting 10x the metadata storage. So that's how you would use MD on SSD phase 2 right now. And there's some lower level tunables through properties that could determine, for example, how frequently do you checkpoint, what is in memory to the metadata blob and other settings. And I think there's still a lot of experimentation to go to find the best settings for that for a production environment. But at least we have everything in place right now so people can start experimenting. And I think that's it from my side. Yep.
Thanks, Michael.